Hey there, good morning Algebra 2 students. I hope you're all doing well. It just dawned on me this morning that it's been 17 days since I've seen your wonderful faces and I miss you so very much. I hope that you're being able to understand everything and more importantly that you're all okay where you're at. And I want you to know, make sure that if you have anything that I can pray for you about, make sure that you remember to reach out. All right, so moving on with the algebra, we've got to work more on solving square root and radical expressions. We need to expand on the idea of yesterday where you can undo a square root by squaring. So let's take a look here. If you recall, we have to isolate the square root before you can actually begin to solve it. That part comes over from yesterday. So what we need to do here is subtract 3. Notice that it is not under the radical. Sometimes what problem I see with students is accidentally making a radical go too far and include too much. So be very careful where your radical ends because that's an on purpose type of a thing. So we take away the 3 and you get an expression x minus 3. And you know that in order to undo a square root, you have to square it, just like we talked about yesterday. So we can go ahead and square that. Now my big caution to you is be careful with this one, because although the whole purpose is just to take the square root and make it disappear so that you've got 5x minus 1, on this side, remember it's a binomial squared. And since it's a binomial squared, you need to think of it in terms of the pattern for a binomial squared, or just simply remember that it means x minus 3 times x minus 3. Okay, remember our pattern is that you square the first, you square the last, and double the product of the two. Sometimes that's harder to remember, so if you need to, you can do this like this. And remember that x squared minus 3x plus 9 will give you x squared minus 6x plus 9. And yes, these do get more complicated than the things that we were looking at yesterday, but you are fully prepared to be able to handle that. So we have a quadratic here, but in order to solve the quadratic, remember you have to have a 0 on this side. So that should remind you that what you need to do here is remove the 5 and add the 1 from this side, but you have to always do that to both sides of an equation, as you know. So we take away the 5x and we add the 1, lining things up to get our quadratic equation that's equal to 0. And you know that there's many ways to do that. You've got quadratic formula. This one, though, is very, very easy to factor. You always want to look for the easy things to do first, like factoring. If you recall, you're looking for factors of 10 that give you negative 11. So you would be looking for a negative and a negative. You can use your little chart that we did in the past, but since this isn't the factoring lesson, you would look back on those things for factoring. But for right now, hopefully you remember that negative 10 times negative 1 gives you 10, but when you add them together, you get negative 11. So we've got that factored. So that would mean that x minus 10 equals 0, or x minus 1 equals 0. So x is 10 or x is 1. We can't stop there because it says solve and check for extraneous solutions. Our extraneous solutions are actually, we're looking for fakes. Now I've got this covered up again. We know that it says x equals 10 or x equals 1, but we need to determine if there are any fakes. So in order to do that, you plug in your answer and we simplify it down. So this one gives you 5 times 10, 50 minus 1, which is 49. So 7 plus 3 does in fact equal 10. So we know that this one actually worked. Now it is possible in any of these, when you solve them, you'll find out that you've got a couple of answers. Sometimes one will work, sometimes both will work, and sometimes neither will work. And so you have to really look for these fake answers at the end. So for example, the second answer we got 1. When we plug that in, 5 times 1 minus 1. Okay, that would give you the square root of 4. The square root of 4 is 2, and 2 plus 3 is 5, but that doesn't give you 1. Okay, we're looking for the principal square root here. We're not looking for the negative version of it. We're looking for the principal square root. So 5 doesn't equal 1. And so that one is an extraneous root. The only one that truly gives you the right answer is going to be the 10 right here. Okay. So once again, you have to go back in. You have to check the answers. All right, let's take a look at another one. This one's a little bit easier. We have one medium, which was this first one. We have one easy, which will be the second one. And the third one, make sure that you've got your pencils out and ready to follow along lots of steps on the third one, and then you'll be done and you'll be able to go and do the practice that you need to make sure that you can do these problems. All right, so this one, square root, the square root signs are already kind of by themselves. So we can undo a square root by squaring, so we can square both sides of this. And we end up with 3x equals x plus 2. Take away the x from both sides, divide by 2, and very simply get an answer of 1. We do have to check and make sure that that's a real answer, or, well, real not as in real numbers, but one that is not extraneous. So we plug it back in. And this one, even though we didn't bother to simplify the square root of 3, but the square root of 3 does equal the square root of 3. And so that one very nicely and easily is done. And the answer worked and checked out. So our answer is 1 for that problem. So this one, though, we noticed that we couldn't just get one square root on one side. We had 2 square roots to deal with. So our last one also has 2 square roots to deal with. But this one, as you can see, is going to get us into a much more complicated situation. So I've got a lot of things to talk about as we go through the solution of this problem. Okay, first of all, if I tried to square this right now, squaring both sides is not going to completely get rid of the radicals, and neither would be the way that we're going to do it, it's also not going to get rid of the radicals in one step, but it's going to be the easiest method. So what we want to do is, in this case, we're going to isolate the most complicated radical. So we're going to isolate this one, and we're going to move this one to the other side by adding. Okay, so we've added that square root of x to both sides. Now we can square both sides, but we've got to be careful as far as what that will actually do to us. Because when I square this side, that's nice and convenient, because that turns out to be 5x plus 4. But this one, remember, is square root of x plus 4 times square root of x plus 4. Which means that our little radical here is not going to completely disappear. We still have 5x plus 4 over here. Square root of x times square root of x gives you x. Square root of x times 4 gives you 4 square root of x. Square root of x times 4 gives you another one. And then 4 times 4 is 16. Putting it together, we get 8 in the middle. All right, you may have done that by pattern, just going straight from here to here. If you're really good at that, this would have been that squared plus 2 times that plus the n squared. But I put this in just in case. All right, now we've got another thing where we've got a radical, we need to isolate that radical before we can do anything else. So we need to take away the x from both sides. We also need to take away the 16 from both sides. So here's our taking away the x, and here's our taking away or subtracting the 16. And we're left with 8 square root of x. We then can square both sides. If you wanted to, you could divide both sides by 8, but then you're going to have some fractions to work with. So honestly, it's easier to square both sides in this case from here and just deal with the 64 in this spot. So that's what we're going to do. Now we have to square this binomial. All right, I know this is a lot of steps. I know that this one is got basically everything in it that we could possibly have in it. So we need to square that, and we need to simplify over here. This one becomes 64x, 8 and 8, 64, and square root the square. So let's simplify this. You can either do it the long way like this, or by pattern. This will be 4x squared, 2 times this product, and then 144 at the end. Okay, so here's our negative 48x and negative 48x. Now we have this pesky thing over here that you've got to move so that you can have a 0 on the one side. So we're going to subtract that from both sides. You're always doing the same thing in algebra to both sides of an equation. You can do simplifying steps without doing that to both sides, because only where it applies. But whenever you have to quote unquote move something over, you're really doing the same thing to both sides. All right, so we have 160. Now, before you try to do anything with putting in the quadratic formula, these are big numbers. Always look for a greatest common factor first. With a little bit of checking, you'll find that 16 does go into all three of these. So we're going to factor out a 16, because 16x squared, 16 times 10, 16 times 9 gives you these numbers. This one then, hopefully it should click into your mind that it's very easily factorable, because the factors of 9 are 9 and 1, which together give you 10. Got to do a negative and a negative to make a positive, just to review that. Now that leaves us with possibilities. 16 equals 0, but that can't happen. So you're left with x minus 9 equals 0 or x minus 1 equals 0. So our two possible solutions would be either 9 or 1. I'm leaving that hidden because I want to take a look at the checks for these to figure out if one or both or neither of those answers is correct. So we plug in our 9 into these equations. So I've got 5 times 9 plus 4 minus square root 9. And we simplify. 5 times 9, 45, 49, square root 49 minus 3. 7 minus 3 gives you 4. Okay, so this is a correct answer. So what we need to do is we still need to check this one and make sure and see if this one also gives us a correct answer. So when we plug in our 1 into this problem, we get 5 times 1 plus 4 minus the square root of 1. So this would give you the square root of 9 minus 1, which gives you just 2. That's not a 2x, that's an x, as in this doesn't work. 3 minus 1 is 2, that's not 4. So we end up with an extraneous solution there. All right, we're looking for the principal square roots in these. So you've got to watch out for your solutions here. Make sure you're checking them to make sure that you got the right answer, ones that will work in that case. So that's it. That's it for today. I want you to go back. I want you to practice. I want you to do your best on these. I think as a class, you're doing great. So just please keep up the good work. Keep on studying. And I will see you hopefully very soon. And keep praying for our country, for our world, and for each other. Make sure you're reaching out to each other, checking on each other. All right? Okay. Have a great, blessed day. And I'll see you hopefully sooner than later.